Hi guys, so today we're looking at the specific heat capacity. The specific heat capacity is the amount of energy required to produce a unit temperature rise in a unit mass of a material. That C, lowercase c, is equal to the change in energy divided by the mass times the change in temperature. So C is your specific heat capacity. This is measured in joules per kilogram per Kelvin or per degree Celsius. Either one is fine. Q is your energy, measured in joules. M is your mass, measured in kg. And delta T is the change in temperature. And this is always a positive value, so it's always the bigger temperature from the smaller temperature. So it's always positive. Okay. So specific heat capacities are different for different substances because different substances contain a different number of molecules that are of different types and different masses. So even if a substance is receiving the same amount of energy, the same amount of heat energy, the distribution of that heat energy amongst the molecules changes. So therefore, the temperature changes will be different between different substances, which means that your heat capacity is different for different materials. Storage heaters have a large heat capacity. Explain why. This means that they can store a lot of energy per rise of unit temperature. So they can store or hold a lot of energy per rise of temperature by 1 unit. So this means that storage heaters can hold a lot of energy, they can store a lot of energy before their temperature changes by 1 degree. This also means that they release this temperature slowly as well. So they lose energy very slowly too. So they release this energy. Very slowly. So storage heaters work by taking in a lot of energy at nighttime when electricity is cheaper. And then throughout the day, when the storage heater is turned off, it releases this energy slowly. Okay, let's look at calculations on specific heat capacity. In calculations, we use Q is equal to mc delta T. So I'm taking my equation for specific heat capacity. C is equal to Q over m delta T. And I rearrange that so that Q is equal to mc delta T. So when we're dealing with equations with heat, we always want our energy. So our energy here to be the subject. So just remember Q equals mc delta T. So the energy required is equal to mc delta T when there is a change in temperature. So the energy required for a change in temperature is mc delta T. Let's look at challenge 2. Challenge 2 asks, how much energy is required to raise the temperature of 500 litres of water from 20 degrees to 50 degrees? Okay, so let's figure out what we have. So we want the energy required. So I don't know that yet. I want the energy required. I'm told that I have 500 litres of water. So the volume of water is equal to 500 litres. I'm told that my change in temperature is from 20 to 50 degrees. So my change in temperature, I subtract my temperature values from each other. So it's always the largest from the minus the smallest. So my change in temperature is 30 degrees. I'm also given my specific heat capacity of 4,200. I'm given my density of water of 1,000 kilograms per meters cubed. And I'm told that 1 litre is equal to 1 by 10 to the negative 3 meters cubed. Okay, so I want to find the energy for a change in temperature. So the energy required for a change in temperature. So how much energy is required for our water to heat up from 20 to 50 degrees? So anytime we're looking for the energy required for a change in temperature, we use our equation Q equals mc delta T. Okay, so to find Q, I need the mass, which I don't have. I need the specific heat capacity, which I do have, and I need the change in temperature, which I also have. So first off, you need to find the mass. So you need to find the mass of the water first, before we can get the energy required. Okay, so we need to find the mass of our water. So what information do I have for my mass of the water? Well, I'm told that the density is 1,000 kilograms per meters cubed, and I'm told the volume is equal to 500 liters. Do I have an equation that links mass, density, and volume? Yes, I do. I know that the density is equal to my mass divided by my volume. So I can find by mass because I have my density and volume values. But don't forget, you need to convert your units first. So if I have my density in meters cubed, I must get my volume in meters cubed as well. So I'm told that 1 litre is equal to, by 10 to the negative 3 meters cubed. So if I want the volume of 500 litres, it's 500 by 10 to the negative 3. So my volume is equal to 0.05 meters cubed. Okay, so to convert my value from litres into meters cubed, I multiply it by 10 to the negative 3. From here, I want to find my mass, so I substitute my values into my equation. This gives me 1,000 equals my mass divided by, that should be 0.5 meters cubed. And I want to find my mass, so I cross multiply. This gives me 1,000 times 0.5, which gives me my mass of 500 kg. Okay, so now that I've found my mass value, just going to highlight that here. Okay, so I find my mass value. So now I need to find my energy required. So my energy required, Q is equal to mc delta T. Q is equal to 500 times 4,200 times my change in temperature of 30. And substituting all of this into my calculator gives me my final value of 500 times 4,200 times 30. So 63 million, or we can write this as 6.3 by 10 to the power of 7 if we prefer. Okay, please pause and take down this example.